Good evening, GCC College Algebra. Coming back to you again, continuing chapter 12.3, still talking about solving systems. Boy, 12.2, that was a tough one. Solving systems with matrices and using row operations. Very confusing, very frustrating. I wish it was easier. I wish there were some shortcuts, but it is what it is. Very, very difficult lesson that one was, wasn't it? Moving on now, we're going to talk about solving systems of equations using matrices, but this is a whole completely different approach. This is something completely different here. And there are two skills you need to know. If you can do these two things, then these two very basic skills with matrices, something you've never seen before, if you can do these, solving this method actually becomes very easy. It's not like that last one with row operations, where sometimes you don't know what you're doing and you kind of spin out of control. This one is a lot nicer. So this is solving system, another approach using matrices. All right, before I start, I just want to kind of review that if I have a system of equations, something like 2x minus 3y equals 7, and negative x plus 5y equals negative 1, I can rewrite that. This is a system of equations, two equations with two variables. I can rewrite that as an augmented matrix using the coefficients of x's and y's augmented with the constants. And then, of course, 12.2 was all about using row operations here to make that a 1, to make that a 0, to make that a 1, and to make that a 0. Well, we're going to do something a little bit different here. What we're going to do is we're just going to look at the matrix formed by just the coefficients. So if I've got just the coefficient, because this is the coefficient matrix, would be a nice, well-behaved square matrix, 2, negative 3, negative 1, and 5. That's the matrix we're going to be working with. Now later, we'll see that the constants do play a role in here, but I want to talk about this little coefficient matrix, this little square matrix. We call it a square matrix because it's got the same number of rows as it does columns. And this is what we're going to be working with. The first skill we need to be able to do is find something called the determinant of a matrix. Determinant. Oh, did I spell that right? Let's see. D-E-T-E-R-M-I-N-A-N-T. Determinant. Okay, there. Find the determinant of a matrix. Now, we've never talked about this. What is the determinant of a matrix? Well, it's a formula. So if I have a matrix, let's say I've got matrix A is, and I'm going to just put some entries in there, little a, little b, little c, and little d. If I want to find the determinant of matrix A, the determinant would be written like this, little a, little b, little c, little d. Or I could write the determinant of matrix A. I know that looks like absolute value, doesn't it? It looks like the absolute value bars, but it's not, because this is matrix math. So we're using the same symbols, but it means something completely different. The determinant of matrix A, it's also sometimes called capital D for determinant, is this. Now this is the actual proper matrix. This means the determinant of matrix. And the way we calculate the determinant of a matrix, I know I keep using that word, and it's like, well, what is it? What is the determinant? The determinant of a matrix is a number. It's a special number that can be used to help unlock the matrix. So the determinant of the matrix is found by this formula. A times D minus C times B. And the way I learned it, I kind of learned a little trick here. I learned this. A times B minus C times B. A times D minus C times B. That's the way I learned it. All right, so let's so hopefully that little trick will help you to remember how to do the determinant of a matrix. Let's get a matrix and find the determinant. So evaluate Gosh, I keep picking up different pens and they're all going dry on me. I'm doing so many. Here, let's see. 3, -2, 6, and 1. So this is evaluate the determinant of this matrix. Let's see. I haven't used green in a while. Let's see what happens there. So it's going to be 3 times 1 minus 6 times -2. 3 times 1 is 3. 6 times -2 is -12. The negative of that is positive 12. 15. The determinant of that matrix will be 15. All right, let's do another one. Have I used this black pen yet? Let's see. Find. Gosh, there's another one that's gone back. Find the determinant of matrix 3, 1, 0, -2. All right, again, same process. This times this minus that times that. 3 times -2 minus 0 times 1. -6 minus 0. The determinant is -6. All right, so that's the first skill. Now, it's going to get confusing now because we're going to talk about a process using determinants in order to solve a system of equations. But focus in on this skill. If you can find the determinant of a matrix, then you can do this. It really is just finding a bunch of different determinants. You're going to be finding 3 or 4 different determinants as we go through. All right, so this is this process was discovered. You know what? I'm going to put these pens aside here. Let's try this one. I don't think I've used this one in a little while. So let's, given the following system of equations. Suppose I've got the system 3x minus 2y equals 4, and 6x plus y equals 13. All right, so we're going to solve this system using Kramer's rule. Kramer, like the guy on Seinfeld, but no, not the guy on Seinfeld. Kramer was a mathematician, lived a long time ago, and he found a way of solving a system of equations using determinants. Okay, so what I'd like to do is I want to go through this example step by step, and remember, if you can find the determinant, then you can do it, because it's just a bunch of determinants here. Okay, so what we're going to do is we're going to find, first we're going to find the determinant of the coefficient matrix. 3, -2, 6, and 1. We're going to call that D, the determinant of the coefficient matrix. So just the coefficients, 3 and -2, 6 and 1. Notice the x's line up, the y's line up. These are my x's, my y's, first equation, second equation. And I'm going to do this trick. 3 times 1 minus 6 times -2, 3 plus 12, 15. There it is. Second, we're going to find what they call the determinant of the X matrix. Determinant of the X matrix. All right, so what the determinant of the X matrix is I'm going to have the same values, 3 and 6, -2 and y, but instead of the coefficients of the x, I'm actually going to put in the constants. So instead of having the x's, I'm going to take the x's out, and I'm going to put in 4 and 13, and leave the y's in there, -2 and 1. So here, I've replaced, where's my highlighter? Where's that highlighter? I know I had a highlighter around here somewhere. There it is. So the determinant of the X matrix, I've replaced the X values with the constants. And now I'm just going to find the determinant. So this is going to be 4 times 1 minus 13 times -2. 4 -26 plus 26 is 30. One more to go. Next, we're going to find the determinant matrix Y. Can you imagine what we're going to be doing here? We'll leave the x's in, the 3 and the 6, but this time we're going to replace the y's, the -2 and the 1, with the constants, 4 and 13. So in the determinant Y matrix, I've replaced the y's with the constants. Find the determinant here. Again, use this trick. 3 times 13 minus 6 times 4. 3 times 13 is 39. Minus 6 times 4 is 24. 39 minus 24 is what, 15? All right. So I know it's confusing, and you're thinking, well, why are we doing this? What on earth are we doing this for? There is a proof for Cramer's rule, a very long, kind of drawn-out proof that shows you why this works. But honestly, as long as you're able to do this and do these determinants, that's all that's important. If you're not sure why this is working, well, that's okay. Just know how to do this. All right. So we had the system of equations. Here was the original system. We found the determinant of the coefficient matrix. We found the determinant of the x matrix. We replaced the x's with the constants. We found the determinant with the y matrix, replaced the y's with the constants. And now we actually have the solution. The solution says that, let's see if this blue one works, that the x value at my solution is d sub x over d. The y value of my solution is d sub y over d. In other words, the x value is d sub x, which is 30 over 15, and y is d sub y, 15 over 15. Ladies and gentlemen, the solution to this system is the 0.21. The x value at my solution is the determinant with x's replaced over the determinant of the coefficients. 30 over 15 is 2. The y value of the solution is the determinant of the matrix with the y's replaced by the coefficients over the determinant of the coefficient matrix. 15 over 15 is 1. So and that's it. That's the solution there. Gosh, let's see. Let's do another one of these. Can be very kind of confusing, but once you're doing the determinant, really that's all there is to it. This is one of those lessons too where when I do it in class the first time, I don't really worry about it. The first time I just go through at regular speed, and only a few people really get it the first time through. Try to make sure that everybody's always taking notes, so you've got it in your notes. And then the second time I go through it, I slow down a little bit more, spend a little bit more time on it, make sure that everybody's with me, and usually people are fine. And then more people get it, and then by the third time I go through it, usually people are seeing it pretty good. So let's look at an example. This is going to be number 16 out of the exercise set. X plus 2y equals 5, and x minus y equals 3. There's my system. And I'm going to solve it using Cramer's rule. All right, so in Cramer's rule, I have to find those three matrices. I have to find the determinant of the coefficients, the determinant with the x's replaced by the constants, and the determinant with the y's replaced by the constants. All right, so here we go. The determinant of the coefficient matrix is going to be the determinant of 1 and 2 and 1 and negative 1. If I replace the x's, then it becomes 5, 3, 2 and negative 1. If I replace the y's, it becomes 1 and 1 and 5, 3. So again, notice that this is the determinant of the coefficients. Determinant with x's, I replaced the x's. Determinant of y's, I replaced the y's. And if you can find these three determinants, then we know that the solution is going to be, the x value is going to be, the x value of the solution is going to be this, whatever this determinant is, over that. The y value will be whatever this determinant is over that. So let's find the determinants. Again, use this trick. 1 times negative 1 minus 1 times 2. Negative 1 minus 2 is negative 1. There's my first determinant. Oops. Oh gosh, what a silly mistake. Did you catch that? 1 times negative 1 is negative 1. 1 times 2 is 2. Negative 1 minus 2 is negative 3. All right, now the determinant with the x's replaced is going to be 5 times negative 1 minus 3 times 2. Negative 5 minus 6, negative 11. And then 1 times 3 minus 1 times 5. 3 minus 5 is negative 2. All right, horrible numbers here. Not very nice numbers. So let's put them all together now. The x value at the solution is going to be the determinant with the x's replaced over the determinant, which is going to be negative 11 over negative 3, which is 11 thirds. The y value at the solution is going to be the determinant with the y's replaced over the determinant, negative 2 over negative 3, 2 thirds. Therefore, the final answer to this problem, ladies and gentlemen, is the point 11 thirds, 2 thirds. Horrible fractions. But think about all the other fractions that you've had to deal with. You know, working with fractions has always been kind of awkward and difficult and frustrating, working in those solving systems. But here, I get a fractional answer, but I didn't ever have to work with fractions. It didn't come out until the very end. Getting this horrible answer here. All right, let's look at, oh, by the way, there is a place where this can go all horribly go wrong. Can you imagine? Did you see it? This is something where in class I would probably do an example of this, and I think one of the homework problems, this is going to happen, this will happen in one of the homework problems. Notice that the x answer is the determinant of x over the determinant. Well, what if the determinant was 0? What if I had a system of equations where when I did the regular determinant, it came out to be 0? What does that mean? It actually does not mean there's no solutions. If the determinant is 0, the only thing we can say is we cannot solve it with Cramer's rule. We have to do it some other way. So if the determinant is 0, we just say can't be solved using Cramer's rule. We have to pick some other method to solve that system. Can't be solved using Cramer's rule. All right. In the homework tonight, we can also do the same method using 3x3s, but that gets a lot more confusing. I have not assigned any of those for tonight's homework. I haven't assigned any determinants of 3x3s. We're really just focusing in on the little 2x2 equations. Number 24 in the exercise said it's interesting because it can't be solved with Cramer's rule. That was the one that I would do in class to show you that you get 0 as a determinant and can't be done. Really, that's all there is to this. It's the kind of thing where if we were in class now, I would do a bunch of examples, kind of watching very carefully, okay, who's got it? Are we ready to move on or not? And most times, by the time I get to the third example, like I said, most people have got it. They're ready to move on. So let's just try one more example. Solve using Cramer's rule. Solve the system using Cramer's rule, which is determinants of matrices. Let's say I have, this is, let's see, what one did we did? We did 16. 18 is kind of a nice one. 22 is a pretty good one too. Let's do 22. And it says 2x plus 4y is 16. And 3x minus 5y is negative 9. There's my system. 2x plus 4y equals 16. 3x minus 5y equals negative 9. Now, if I was allowed to solve this any method I want, I don't think I would want to do it graphing. Elimination, if I multiplied everything in the top equation by a 5 and everything in the bottom equation by a 4, I'd have 20 and negative 20. The y's would get eliminated. I could do it that way. Substitution, Well, let's see. If I subtracted the 4x, that is a 4. Gosh, my 4s look awful, don't they? I'm going to blame it on the pens. My pens are beginning to run dry and go blunt. I've got, you wouldn't believe how many pens I've got here. It's a little ridiculous. I've got going through all of these. I know, look at this. All these pens that I bought, and pretty much almost all of them are dry. They're just, yeah. All right, enough of that. Oh dear, I'm making a mess here. Somebody help me out. I try to put the dead ones back in a little can and let them. If you leave them point down like this, the ink will dry down, and then you can get a little bit more use out of them. All right, so that's a 4. If I subtracted the 4 y's from both sides and divided everything by 2, I'd get x equals negative 2y plus 8, and then I could plug that in there, so I could solve it by substitution would be nice. If I put it as an augmented matrix, well, 3 minus 2 is 1. I get the 1 there nicely, and going forward from there, I think that would be a tough one. But as you're going to see, and one of the things that you might, after you do a couple of these, you might realize that Cramer's rule, although sometimes takes a little bit longer, is actually the easiest method. It's really straightforward. It's very simple. It's very formulaic. You just have to do the 3 determinants, it's just, you don't have to think too much. So first we're going to find the determinant of the coefficient matrix, which is 2, 4, 3, and negative 5. Notice I'm using these straight brackets. That means determinant. If I put brackets there, that would just be the matrix. But this means the determinant. And I'm going to use this thing right here, 2 times negative 5 minus 3 times 4, negative 10 minus 12, negative 22. Now I'm going to find the determinant with the x's replaced. So instead of the x's, I'm going to put the 16 and the negative 9, and then 4 and negative 5 for the y's. So 16 times 5 times negative 5 minus negative 9 times 4. 16 times negative 5 is negative 80. Negative of negative is a positive. 9 times 4 is 36. So that's what? Negative 44. And then I'm going to find the determinant with the y's replaced. So put the x's back in there, 2 and 3. The y's, I'm going to put in the 16 and the negative 9. And again, do this thing. 2 times negative 9 minus 3 times 16. 2 times negative 9, negative 18 minus 3 times 16. 3 times 10 is 30. 3 times 6 is 18. So what's that? 48. 48, 58, 66. All right, so now that we've got them all, we just need to put them all together. Let's see if I can, no, that's not enough room. I'm just going to continue down here. So the x value at the solution is going to be d sub x over d, which is negative 44 over negative 22, which is 2. The y value at my solution is going to be d sub y over d, which is negative 66 over negative 22, which is 3. Therefore, the solution to this system of equations, where they intersect, is the point 2, 3. Notice that one of my determinants, if d sub x or d sub y turns out to be 0, 0 over anything is going to be 0. And it's totally possible that they intersect at 0. The only problem is that the determinant of the coefficient matrix cannot be 0. If it's 0, you can't divide by 0. Now that doesn't mean there's no solutions. What it means is you cannot find the solution using Cramer's rule. That's all it means. All right, so there's Cramer's rule. So what I'd like you to do now is go ahead and do assignment 12.3. It starts on page 901, and I want you to do 7 and 9 are just finding determinants. It's just two quick little finding determinants. And then I want you to do 15 through 29 odd, which are a bunch of solving systems using Cramer's rule, what we just did. Okay, and if the determinant of the coefficient matrix turns out to be 0, then all you can say is you cannot solve it using Cramer's method. That's all we know. Once you're done, I want you to email the completed assignment to me. I'll grade it and put it in the grade book. Remember, you can scan it and send me a PDF. I've been getting some weird stuff, so please either PDF or JPEG formats. You can take a picture of it with your phone and then email me the JPEG picture, or you can scan it and send me a PDF. I've already talked to the one student was sending me stuff and I couldn't read it. I couldn't open it. And I sent them back, and I asked them to send it in a different format, and they just took pictures and sent it to me. But either one of those are usually the quickest and the easiest ways of doing it. If you've got any questions, you can also shoot me an email. I've been getting a lot of emails every day. I spend several hours every evening grading and going through emails. So please be patient. If I haven't emailed you back yet, I try to get back as soon as possible. Guys, keep working, keep going, and this lesson's not so bad. This one should be nice and comfortable. We had a really tough one yesterday, so this one shouldn't be so bad. All right, guys, good luck. I'll talk to you again soon. Bye.